Last time we were looking at finding standard deviation, or standard deviation that we were finding last time. It was just where we had an x and we had to find the deviation from the mean, of which that deviation from the mean was x minus x bar. That part is the deviation from the mean. And we actually said when you add that part, it will give you a 0. You will see the importance, the significance of that part where when you add, you are getting a 0, especially when we'll be doing, dealing with what is called regression line. Because on the regression line, we will meet again the very same part where we will have deviation from the mean. That's why, to avoid that, we had to square, right, another part we had to square, and then that part, that way we are squaring, we had to assemble it, to add it up, and then when we add up, we are dividing by n. And what we are finding when you divide by n, that is your variance. But now to find the square root, to find the standard deviation, you have to square root that variance. The fact that you are square rooting the variance, what you are getting, it is the standard deviation. And actually, we came up with this conclusion that when the standard deviation or the variance is very small, if you are comparing the two items and you find that the standard deviation or the variance is very small, it signifies that if it is a machine, that machine is very powerful. And that is very reliable. So reliability is coming in because when the standard deviation is very small, if you are to compare two sets of data, where you are comparing two sets of data is when now you have what is called, you want to find out how reliable the data is. So the formula that we used, last time, we had to use this formula where we had to sum up, x minus x bar squared divided by n, and this one you are finding your variance, and that is your variance. That's what we came up with, right? And then we said if you see such is the case, to find the standard deviation, what you are coming up with, it is something like this, where you have to sum up x minus x bar squared divided by your a. That is your standard deviation. But again, we have to look at that if you have to sum up all x's divided by n, what you are coming up with is your x bar a. You are summing up whatsoever and you are dividing by n. What you are getting is the mean. That's what I would have. In terms of, this is the mean of a small sample. But where you have got the mean of where the sample, where the items are so many, actually, where you are looking at a sample where we have got the items are so many. So, to find the mean, what you are looking at, it is you have to look at the sum of, like this one, a minus 1. But we are not looking at this one. We are only actually just looking at not minus, so we are just looking at this element. We are not subtracting whatsoever, and whichever, but we are looking at this as the mean. Today, we want to look at another method where we are going to use this. We are going to reduce this to another area of interest to make it a little bit short. Remember, if you look at this, the way this has been written, if you look at that, this one, it is the same as 1 over n summation of x minus x bar squared. Something like this. This is the same. If you feel it's not the same one. Sure. The moment we have written this, it's the same as 1 over n summation of x minus x bar squared. So look like that. You remember that? You know that? Just listen. Here we are dividing by n. The same as 1 over n. This n is this one. In other words, we are taking all this one divided by n. That's why we have got this one and it's the same as this one. You get it? I'm setting it from there. I'm setting it from there. Right. I want to deduce something. I want to come up with something which will be very, very useful so that you have to be able to sort out the standard deviation of the variance, but using a short method. That's what it was. So I am taking it. I'm studying it from here. Get your paper where you can write, and then I'll explain. I'll explain later. I'm taking it from here. Taking it from there. So yes, I'm studying it. When you're done, you explain it. Nice. Kemudian, akhirnya, karena proceed. Right. I'll just explain. This, when you what we were doing last time seems to be it was very difficult. It was very difficult. Now we are making work to be very easy. That's why instead of using that formula that we are using this one, where we are divided by n sort of like that, we'll be using this one. We're going to be using this formula here instead of that. We will do the same problems that we have been doing, but we are going to use this formula here instead of the one that we use. In other words, what we are saying is You see, last time we were looking at something like this. We had to use the sum of x minus x bar squared over a to find the variance. That's what we are looking at last time. We have to use this one. But we use this one that time. Right? We were adding divided by n, but now we are not going to use that one, this one, because this one seems to be very difficult. We are using this one. So we are using instead, we are using this formula here. X squared over n minus x bar squared. We'll be using this one instead of this one. Okay, we'll be using. This is actually so easy than this one, and you will see why actually it is easier than this one. Right. Let me just explain a little there, and thereafter, then I have to tell you exactly what we need, and then I have to give you an example so that you can see what we're trying to say to me. Right. If you look at this one, of course, I don't want to trouble you in an exam. The question I would have asked you a question in an exam. Can you deduce? I would have said deduce this to come up with this answer here. So that you explain everything up there. But because we are all people, we have to start again, while remembering this and that, I don't want to talk to you. Right? What I will do is I will just give you a problem statement. I'm not giving you the same this. But if you are reducing this one, what you have to do is this one is the first formula that we use. Sum of x minus x bar squared divided by n is the same as this one. Now, if you look at this part here, it means you are expanding. Remember at MSCE, you have to do something like this. You have to do with a minus b, something like this, squared. Right? At MSCE, it was saying a minus b, then a minus b. This format is the same as this format which is inside. Take this to be your a and this to be your b. That's what I'm saying. Now, when you do like that one, when you are expanding, you are doing something like this, right? You are doing something like that. Okay, you have to do something like this. You have to do something like that. Of which is to say a times 8. So it will be a what? Squared. A times b minus ab. B times a minus ab and a. And this one is plus b squared. If you look at this one, you are saying it's a squared minus 2 minus. You just added this one minus here. You say 2ab plus b squared. This one we have obtained here is exactly this what I have obtained here. It's the same as this one. It's the same as this one. No, it's this one. This is your a and this is your b. So if this is your a, it is a squared, is this one. If this is your b, 2 minus, it is this one, 2 is this one. A, it is this one, your b is this one. A is this one, your b is this one. Plus, this is your b, it's going to be b squared, it's the b squared is this one. I've just expanded the way you do it at MSCE. You get it? We forgot. We forgot, okay. Alright. I'll come again. And from there, so from this, if you look at that, the moment you look at this one, this is your A, your B, you do it like that, or you are expanding, come up with that. Now, the moment you reach here, you are summing everything now. You are removing this summation. Is you are summing x squared. You are taking the summation inside. You are taking summation inside. You are taking summation inside. Now here, the moment you go, this is minus. You can't sum all the minus numbers. That's why I have just put the summation of the x's here. Plus the same summation here, which is here. So in other words, you are summing everything. You are summing everything. You are summing everything. That's why the summation is here. Now, if you are summing like that one, because already this is giving you, when you are summing this one, it gives you 0. You divide it by n. So you divide this by n, you divide by n, you divide by n. The moment you divide by n, automatically, this one, it will be like this one. That's why I'm going to again this one. Because blue and that, this You say you are going to come up with like similar like that. You are dividing by n, you divide by n, you divide by n. Now, what and here you are putting n, I have another n. Why do you have another n? We are dividing by n. Here, the reason being that we want to only have this one. That's why you make sure that when you are dividing by n, you multiply by n so that you won't very constant here. You want to very constant like that. So the only way with this constant is an automatic that this side is this one. If you look at there is a plus. If you look at this side here, it is minus 2x bar and x. Already this one will diffuse. So it is a plus and minus, it gives you minus, and the what remains there is going to be something like this one. And this is the one that we are going to be using. I'm not saying that you can love to understand everything that is there. No, but what you have to know is that we just know from here. We are not just from there. That's why we are starting it from here. That's what we are looking at. We are starting it from here. Don't make we starting it from here and I think it works. If you want to find out more about how this is done, you can go find out from your YouTube. I think YouTube can be able to explain about that for your own sake. But I'm not, what I'm saying is, I'm saying that this formula here can be the same as this one. Let me now give you an example. I'm giving you an example. I'm saying, forget how we can use this one, forget how you can use it, but what I want to take, you have to take this one. This one. You take this one, that's what I want you to take. So let me give you an example. Giving you an example. An example, this one, the mean of 5 numbers. The mean of 5 numbers the mean of 5 numbers, and these numbers is 2, 3, 5, 6, and 8. 2, 3, 5, 6, and 8. The mean is 4.8. The mean is 4.8. Calculate the standard deviation. Calculate the standard deviation. This is method 1, now we see method 2. We start with method 1 here. Method 1, we use method 1, the old our first method, and then we are using method 2 here. Method 2 here. What does that mean? The mean of 5 numbers is 2, 3, 5, 6, 8. The mean is 4.2. In other words, when you add 8 plus this plus that plus that plus that, divided by how many numbers they are, the answer they are getting is 4.8. Even if you do it, that's something like that. The mean. If you add this plus that plus that plus that, divided by 1, 2, 3, 4, 5, your n is 5. The answer is going to be 4.8. But now the 8 plus this one 14, 19, 22, 24. 24 divided by 5. Less than 24 divided by 5. Do that, 24 divided by 5. It's 4.8. That's what I'm saying. Let's find the standard deviation. Method 1 is this one. You have to do something like this. X Your x's are 2, 3, 5, 6, and 8. Method 1. And you have to come up with something like this. X minus x bar. In other words, your x is this one. 2 minus 4.8. 3 minus 4.8. 5 minus 4.8. 6 minus 4.8. 8 minus 4.8. Right? Let's do that. Can we be doing fast? You get the answer here. You get the answer there. 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 Then the second one is this column here. X minus x bar squared. The first one, what will be that? 2 minus 4.8. This what? Say negative, right? Negative 1.2. The other one? Negative 0.2. The other one? 0.2. 0.2. The other one? 2.2. The other one? 3.2. I don't know whether our friends are getting that. Yeah. Negative 2.8 is that? Negative 1.8 is that? 0.2 is that? 1.2 is that? 3.2 is that? Eh?
Numbers, the fourth one, 1.2.
The fourth one, this one, eh?
Yes.
You 1.2 square. We're putting this one. You square. This one was minus 1.2 minus 0.2, 0.2, 1.2, 3.2. Then you square that. Yes. You are squaring this one. When you square this one, what is it giving you? 1 point. It's going to give something like this. Huh? Can you square minus is the same as 1.2 square. 1.2 square. People, what is that? Is that 1.2 square? Hey. 1.2 square. 1.44. The other one? 0.2 squared.
0.04.
Alright. 0.04. The other one? 0.04. The other one? 1.44. The other one? 3.2 squared. 10.24. Right? Let's start with this. Let's find the sum here. Let's add that. When you add that one, add. The first one is what? 2. Yeah.
2.8.
2.8. Ah, that's the 2.8. 2.8. 2.8 squared equals what? 2.8 squared gives us 7.84. Right? 7.8 what? 4. Two point eight. And the other one, 1.8. Here, 1.8 is not the sum that you are getting. And that one is one, if it is 1.8, gives you, when you square that one, gives you what? 3.24. 3.24. There should be something like that. Add that gives you 22.8. Check that. Huh? Various squared is equal to 22.80 divided by how many numbers are there? 5. Right? And this gives you 4.56. 4.56. Therefore, your standard deviation, you are finding the square root of that. 4.56, which gives you 2.14. 2.14. Are you together? Madam Celine? Huh?
Yes.
Are you not lost? Okay. Let's do method number 2. The method number 2, if you want this method number 2, what we are saying, to find that we are saying it was something like this, squared over n minus x bar squared like this. When we reduce, we came up with something like this. From the formula that I gave you from that one, we have to reduce here. Down, we have to reduce something which was like something like this. Now, I'm saying this one is very simple than this. Let me tell you why it is simple. It is simple because you are going to have only two columns. One column should be an x, another column should be x squared. That's it. You have two columns. You don't even have to come up with 1, 2, 3. You have two columns here. So you are going to have something like this. This is your x. This is your x what? Square. The x square is this. And you know how many numbers there are. And this mean square, you know that it's this square. You know that this mean square is this square. Simple for that one, you square that. And you know how many numbers there are. This side is going to be only this column. That's what it means. You get the answer, it's going to be the same answer. Right. Let's your x is the 2, then x is the 3, x is the 5, 6 and 8. Right? Then here, x squared is here going to be what? 4. Right? 3 squared, 9, 25, 36, 8, 60 what? 64. When you add, when you sum here, it means that you are getting here. Let's add this one. Let's sum here. Let's sum. We have to add here. X squared here. Let's add. What would be the answer here when we add here? 125, 134, 138. Next, so it's going to be 138 divided by 8. How many numbers are there? 5. Divided by gives you 2, 7, 27. 27 point something, right?
27.6.
27.6. Good. Now that 27.6 is what you have found here. You are subtracting mean squared. Let's find mean squared here. Find mean squared. Mean squared, which is the same as 4.8 squared. 4.8 squared. 23.04. Then because here you are subtracting, it means you subtract the 2 here. You subtract. Because of here, you go to this one minus this one. Subtract that. Subtract here. 27.6 minus 23.04. Subtract
4.56.
4.56, right? 4.56. The 4.56 is this one that we got here. Then you find standard deviation. What you are doing, you are square rooting 4.56, and this gives you 2.14 as the same as this one. Which one is easy? This is easier because you just know this. How many numbers? 5. This is mean square. You use that one so that you get it. Instead of taking numbers from there, square them, then do like that. This is how it is. Because what you are doing, you're just going straight from that. Right? Let's come up with another issue now. If you know that one, if you have questions before we proceed, you have questions before we proceed?